Questions? Okay. Next reaction, sulfonation. We just write all the mechanisms one at a time, understand them, go into details if needed, and then add layers as we go. Next reaction is sulfonation. Please remember, sulfonation reaction is where benzene, one of the hydrogens, is replaced by sulfonyl group, converting it into sulfonic acid. So benzene is converted into sulfonic acid, benzene sulfonic acid. And the reagents needed for this reaction is something called fuming sulfuric acid. What is fuming sulfuric acid? Fuming sulfuric acid is basically sulfuric acid that is extremely angry. No? Did it work? That was not good enough for you guys. Anyways, the point is, it's sulfuric acid that is actually very concentrated, but it's also got sulfur trioxide gas. It is so concentrated. See, sulfuric acid is nothing but sulfur trioxide with water. If you take sulfur trioxide and water, mix them together, create sulfuric acid. So fuming sulfuric acid is such a high concentration of sulfuric acid, which is not normal, which is not the one we have. But it is such a high concentration that it also therefore creates a decent concentration of sulfur trioxide gas in it. The fuming part, the gas thing, comes from here. Can we draw quickly the structure of SO3? Please. This guy is the actual electrophile.
Got
Sulfur trioxide gas in fuming sulfuric acid is the electrophile, but can we draw its structure? In Lewis structure. What is it?
2s single bond O's.
2s single bond O? It's SO3.
Is one
Oh,
S?
it's S, and it's single bonded to 2 oxygens.
Two double bond
Two-
oxygens.
yeah.
One single.
What's the total number of valence electrons in SO3?
Oh.
6 plus
Total number of valence electrons?
24.
24. Which atom would you put in the center, sulfur or oxygen?
Sulfur.
Sulfur, okay, and then single bonded to 3 oxygens, okay. How many electrons left? This is taking us back to first quarter Gen Chem. 24 electrons we
2,
started
4,
with,
6,
we used
8,
up 6, so how many
10,
left?
12.
Guys, what is
18.
5 minus 6? 18, okay, 18. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right?
Mhm.
Yeah? 18 electrons gone? Yes?
Yep.
Okay, but does sulfur have an octet?
No.
So what do we do when the central atom does not have an octet yet, but you don't have any more electrons to
Take out a lone pair and replace it with a
Good.
double.
Make a double bond, isn't that right?
Yep.
Okay. Is that what everybody was thinking?
Yep.
That's
Good. What if
exact-
I tell you this is not the best Lewis
No.
structure for sulfur? Because can sulfur expand its octet? What's the structure for sulfuric acid, anybody? What's the best Lewis structure for sulfuric acid?
attached to
Is it
two
this?
attached to two hydroxide groups and 2 oxygens.
Is that the best? Guys, this is something you've done first quarter Gen Chem, 161.
No.
Yes.
No.
Oh,
No, I was answering.
I thought 161. What do you mean you haven't done? No, right?
Yeah.
What is the better Lewis structure for sulfuric
Oh.
acid?
Two double, sulfur has a double bond with two of the oxygens,
Yes.
and then it has a plus charge. and-
Why? Because sulfur can expand its octet. Do you guys
Mhm.
remember this?
Yep.
So similarly, the Lewis dot structure for sulfur trioxide, the best one is not the one that's currently on the screen. The better Lewis dot structure is where all atoms have as low a formal charge as possible. And because sulfur is able to expand its octet, that ends up being this, where every atom has zero formal charge. The best Lewis dot structure for any molecule or ion or whatever it is, where all atoms have the minimum formal charge as possible. And sulfur can have more than 8. It has d orbitals, so it is able to easily expand its octet. So sure, you can, but I would cross this out. This is the better Lewis dot structure for sulfur trioxide. Of course, there are lone pairs, 2 lone pairs on each oxygen to make up the total 24 valence electrons for the molecule. But the point is though, sulfur trioxide is the electrophile. You don't have to, nothing has to be done to generate an electrophile for this reaction because the electrophile already exists. So therefore, benzene comes and attacks the electrophile because it already exists. By the way, sulfur and oxygen, do you expect that to be a polar bond or not? SO bond, should it be polar or non-polar?
No.
Non-polar?
Really?
Polar.
No, it can be one or the other. You gotta pick one. You only get one chance because it's only 50-50%. Is it polar or non-polar?
Be slightly polar.
Say again?
Slightly polar.
Why slightly polar?
Well, I was thinking because there's.
Um,
the oxygen, the
I don't
sulfur
know.
might be pulling a little more than
It's
the oxygen.
it's
Why
po-
should it be pulling a more than sulfur?
It's farther down.
Is that so?
it's polar.
No, it's further down in the periodic table than oxygen, so?
It's bigger.
So?
More electronic.
Guys, oxygen, sulfur, which is more electronegative?
So
Sulfur.
oxygen.
Ooh!
Oxygen.
Since when?
Oxygen.
Guys, we can't do this. This is Gen Chem stuff. This is the baby
Oxygen.
stuff, right?
Oxygen is.
Way more electronegative than sulfur is. Isn't that right? Fluorine is the most, electronegativity increases this way and it decreases going down the group. So sulfur is less electronegative than oxygen. Isn't that right?
Yep.
Yes?
Yep.
Yes?
Yes.
Everybody?
Yes.
Okay. What else? Isn't there also a pi bond?
They're also
What can pi bonds do? So sure, the bond is polar because oxygen, higher electronegativity is pulling the sigma electron density towards itself. But what about the pi bonds? What
Re-
can pi bonds
resonance?
do? Resonance.
Resonance.
If it does resonance, what's the resonance? One of them we already drew earlier, which I crossed out. But isn't that possible?
Yep.
What are the charges and what?
Positive on the sulfur, negative on the oxygen.
So what's the hybrid? Remember, resonance structures do not exist. What exists is the hybrid. What's the hybrid?
Dotted line between the two.
between
All
the
three.
sulfur and all three oxygens.
Isn't that right?
Because it goes.
So if anybody asks you, is sulfur-oxygen bond polar? Your answer is,
Yes.
heck yes.
Yes.
Heck.
Agreed?
Heck.
You can say hell yes too.
No heck. Heck.
But the point is definitely yes. It's not just about electronegativity, which of course is true, but it's also resonance. Everybody with me? Yes? So the next question, if that is the case, what is the electrophilic center in sulfur trioxide? Which atom will the benzene attack?
The sulfur?
Exactly. Because sulfur is the one that has the partial positive, isn't that right?
Yep.
Sulfur is the one that's losing electron density, so that is the electrophilic center. You guys with me? So when the nucleophile, one of the pi electron bonds attacks, it attacks sulfur, because then those electron densities can be pushed out to the oxygen. You guys with me? What will that create? What will that create? Sigma complex, right?
Yep.
What does that sigma complex look like? Now this time I'm drawing, and don't get me method of choice, guys. I'm drawing the resonance hybrid this time, just to show you that it doesn't really matter. You can draw any. And this is the carbon with the 4 bonds. It has 2 oxygens, double bonded, and did I draw that correctly? Yes? Did I draw that correctly? With co.
Following the curved arrows,
So-
yes.
And then, what does sigma complex need to do? It needs to lose a proton to recreate the aromaticity. Who's going to take guesses?
The third oxygen.
But from itself, intramolecular, not generally. Intramolecular reactions, meaning within each other, is more prevalent if you can create a 5 or a 6-member transition state. Otherwise, not so common. This is going to be a 1, 2, 3, 4-membered ring transition state. So probably not.
Could just be a base.
Which is what in this case? So let's go beyond, let's think outside the box a little bit. We call this what? What did we call this?
Fuming. Sulfuric acid.
Acid. Didn't we call it that?
Yep.
It's a mineral, it's a non-organic acid. It's an inorganic acid, isn't that right?
Mm-hmm.
What's something common about all inorganic acids? They always exist with
Water.
water. Hydrochloric acid is not an acid unless it's in water. Sulfuric acid is not an acid unless it's in water. Same thing goes with phosphoric acid, nitric acid, inorganic acids. I'm not talking about organic. I'm not talking about carboxylic acids. I'm talking about inorganic acids. Isn't that right? Because for all of these acids, what's the actual acid? What is the actual acid?
The inorganic, it's
What's the actual acid in hydrochloric acid?
water.
No.
Oh, wait.
Since when? What's the actual acid in hydrochloric acid?
H plus.
Okay, good. And if they're all mixed in water,
H3O4.
hydronium. It's all
Hydronium.
about hydronium. It's all about hydronium, right? This is for mineral acids, for inorganic acids. So the point I'm trying to make is, this is the point I'm trying to make. If it is fuming sulfuric acid, which is an inorganic acid, what else will exist in this mixture?
H3O plus.
Okay, what else will exist with sulfuric acid, sulfur trioxide, and what?
H2SO minus. So it's right.
Water.
Don't go that far, not necessary. The point is there's water in this system. Can water act as a base if there is a strong acid? Can water act as a base if there is a strong acid?
Yes.
Heck yes. Is that a strong acid? Absolutely, because the product is so stable, it definitely wants to lose that